Good morning to all. So, welcome back to today's lecture. We will continue where we stopped on yesterday lectures, right? Yesterday we have covered various aspects, particularly we have discussed about the braking efficiency, braking distance, brake factor. So, based on that we will do one problem to understand how the torque developed by the vehicle and the torque developed by the brake system are interconnected, right? By selecting the suitable friction lining. That problem we are going to do that, and also we will have a short discussion about friction materials. Yeah, these are the two things you are going to learn from today's lecture. And I am sure you would know the equation, right? The minimum distance or total braking distance or total stopping distance, both are same, right? That equation I just wanted to write S mini W by 2 C ln, okay, 1 plus E1 square by eta B Vs W plus Vr W cos theta plus W sin theta, right. So, this is the equation. Tell me, you know this is the weight of the vehicle, fine, and the velocity, right, the one which is going to drive, and what else is there? The mu s is, right, this is road addition factor is there. So, what do you understand from this equation? Do you think your stopping distance or total braking distance depends upon the vehicle or depends upon the brake system? Nothing, right? It purely depends upon the road addition factor. You can see that. So, road addition coefficient mu s and the rolling resistance and your velocity and the vehicle weight. So, it does not depends on the type of the brake, size of the brake, nothing to do with that. It is purely depends upon the tire road friction mu s, I have been talking about that one. Then the vehicle balance, right, which is including W, the load, and the skill of the driver, the maneuvering skill, that is very important. The maneuvering skill of driver is very critical for your total braking distance aspect, and top of that the reaction time, right. So, the reaction when you want to apply a brake, right, that reaction time along with the distance, that is also very critical. In fact, if you look at this is the one is given for one standard vehicle, you can see that how does this braking distance or stopping distance vary with respect to different kilometers. You can see that depends on the velocity, right. You can see that this depends on the velocity, and then and again the reaction time. This is what I was explaining earlier. So, this is the brake reaction time, but it is given in the distance aspect, and this is for the level road, that is okay, but we will focus, this is your designed value, then what exactly you are getting the value. So, when you design, you have to make sure that, so whatever you are getting the distance should be achievable within that distance, you can't go beyond that. Okay. So, again this entire thing is depends on the velocity, right, the mu s factor, and finally the skill of the driver. So, those are the things are critical to define the total stopping distance. And also I have just wanted to re-emphasize I have discussed about the selection of friction lining depends on the your mu L value, right. So, the code is clearly given. So, as increasing your mu L value, coefficient of friction of lining, right, the code will change. So, you can see that C within the range D, E, F, G, H, and this is ungraded. Okay. So, this is what you wanted to see that. In fact, we will do a problem here, right. So, please take down the problem. So, you have a Maruti Swift car weighing 12.4 kilonewton is provided with the cast iron brake drum with the diameter of 250 millimeter and wide 50 mm are the front wheels with one leading and one trailing shoe arrangement. So, this is a drum brake system. Yeah, the shoes are actuated by twin piston 30 mm diameter wheel cylinders. The ratio of braking efforts in the front and the rear is given 1.7:1. The pedal ratio is 1.8:1 and the servo assistant is 4.86:1. The diameter of the master cylinder is clearly given 25 millimeter. The maximum pedal force is given 350 Newton and the coefficient of road adhesion is 0.8. Okay. From the brake analysis, find out suitable brake lining for the application as per SAE standards. Okay. Of course, the tire diameter is given as a 650 millimeter. Okay. The way I am going to draw the brake arrangement in the next slides. Okay. So, what do you understand this problem? This is summarizing entire your design brake system, right? It's a design brake system. So, the weight of the vehicle is given, the drum size of the drum is clearly given, and the drum also the arrangement is a shoe, leading shoe and trailing shoe. I will give other information also, and look at how you apply a brake. You have to use your pedal force, which is 350 Newton clearly given. The pedal force 350 Newton is given. From there you have lever mechanism. So, the lever mechanism are will enhanced 1.8 times, right? The lever mechanism will enhance. From there you have vacuum booster that will again further enhance your braking effort 4.86 times, that is clearly given. Okay. So, that is the way happening from pedal to lever to vacuum booster where it goes master cylinder, right. From master cylinder it should reach to finally wheel cylinder. So, all the master cylinder pressure is given in terms of diameter, similarly wheel cylinder pressure is given in terms of diameter. So, that is also given, right. So, that is one aspect, and within that the braking proportion, whatever the vehicle is coming, those information not given, the proportion is given. Your KB front axle and KB rear axle proportion is given. You could see that the 1.7:1. So, 1.7 times is going to your front axle, one part will be the rear axle. Okay. So, the total will be 2.7 KB, right. That's a with respect to ratio aspect. So, that is clearly given. Okay. Yeah, I think we'll do the problem now. So, how are you going to approach? The first step would be you need to understand that the torque developed by the vehicle when it moves with the proportion. That one thing we need to do that. The other side is torque developed by the drum brake system. So, both has to be equated through brake factor and finally find out the corresponding friction lining using SAE standard. Right. This is the way we are going to approach. Yeah. Okay. So, data is given. W equal to 12.4 kilonewton. Okay. Yeah. The drum diameter is given, brake drum diameter also given. (250 mm). Right. Load transfer. When talk about load transfer, right? To front wheel. Yeah. We can have W, right, W into the KB front axle divided by KB front axle plus KB rear axle. So, 12.4 into 1.7 There should be one, that's it. Okay. So your NFA, right? This is NFA, the load transfer to the front axle 7.874 so much kilonewton. So this much the load is not transferred, is coming from the front axle, the reaction load, right? This is coming. Okay. So ultimately from this, what is the braking torque, right? What will be the maximum braking torque at the front wheel? That's what we are going to find out. The maximum braking torque on the front wheels. So what will be the maximum braking torque at the front wheels? TB. The brake, okay, at the FA, right? That depends upon what? FB, FA, right? Into radius of the tire, yeah, RW. So in fact, PB instead of PB, what we can do? NFA, right? We can have NFA into mu s, right? Into mu s into RW. Okay. So my NFA already I know that is 7.8074 into 10 power 3 so much Newton. Mu s given as 0.8, right? The mu s is given as a 0.8. The diameter is 250 millimeter, but we want as a radius, okay, 250 by 2. I'm sorry, is it 250 or 650? 650. 250 for the drum diameter. This is the wheel diameter. So is a W will indicate the wheel diameter. This should be as a 650. Okay. So what is the torque you are getting? A TB front alone, right? You should expect 2.03 so much kilonewton meter. This is the torque at the front wheels. When you talk about, it's a wheel. Per wheel in the front axle. Right. Obviously, it will be 1.015 so much kilonewton meter. This will take it as a equation number 1. Equation number 1. Yeah. We'll take the equation number 1. Now, thus I will draw the arrangement, leading and trailing arrangement. Yeah, this is the arrangement. So, there is a pivot here, right? The pivot arrangement is as shown here. Okay. Just for understanding, okay. And the distance, activation distance is given, right? From the tip of the pivot to tip. This is the tip where this post going to act here, a P. The distance clearly given here is 85, and from here to here is 95. Okay. Then there is one more distance we need to have. So as rotating in this direction, okay, your Fn will be in this way, and Ff, I think please recollect what we derived yesterday. Yeah. So the distance between the tip to the end of the drum, right, that's also given 96. So this is the arrangement. Okay, this is the arrangement. We made simplified. I just wanted to emphasize this is a very simple leading and trailing. Okay, the moment you go for a leading and leading or SDO or dual servo or S cam, then again the arrangement will change. So accordingly you have to find out the friction lining based on the geometry, right? Based on the geometry, just giving information. From here, the shear factor, right? The shear factor for leading, right? Shear factor for leading is your friction force by the activation force, which already we have mentioned that mu L C by n minus m mu L. Which is m, which is m, which is n, which is m, right? Then SF trailing will be again same FF. Only thing is the sign will change. Yeah, mu L C n plus m mu L. Okay, so these are the two equations we need to find out. So from here we know that C equal to 95 plus 85, that's give you 180 millimeter. So what is the m? M is 96 millimeter, right? This is the m, 96 millimeter, and n would be 95 millimeter. That. Okay, fine. Now we got it. So this is the arrangement, geometric arrangement of leading and trailing shoe arrangement. Okay. The question is, now I need to find out the activation force, right? I need to find out the activation force, and also I need to find out the torque developed by the drum brake, right? So what is the activation force? The activation force, how do I do that? How do I find out P? So the first is your pedal force, right? You will have a pedal force Fp, that's one thing is there. Then what is that you want to have? From pedal force to your the lever, that is how much? 1.8 times, it's a magnified 1.8 times, okay, elevated. Then after that what happened? Your vacuum booster, it's a 4.86, 4.86 vacuum booster, fine. What else we have? From there, the moment vacuum booster, then pressure is developed, then from the master cylinder, the pressurized brake fluid will go to wheel cylinder, okay. Whereas the master cylinder has the diameter what? 25, right? The master cylinder has a 25. So the pressure will be very high. The pressure will be very high. But the moment it reaches to the wheel cylinder, the diameter is 30 millimeter. So the pressure will be reduced. So we have to do the proportionate, right? You have to do the proportionate. So 30 by 25 square, right? So that's the area thing, right? So obviously, right? If you do that, and I know my Fp equal to how much? It's a Fp equal to 350 Newton. So if you substitute, can you give me the value? 350 1.8 into 4.86. How does it matter? Because the ratio, so I straight away substitute in millimeter square is going to be cancelled out. So can I have the, what is the value you are getting activation force? 4410 Newton. So that's the value you should expect. 4410 Newton. This is the activation force you are expecting. Okay, that's fine. Yeah. So earlier we found out the brake torque from the vehicle, that already given 1.015 kilonewton meter. Now we want to equate it from the brake drum torque, right? This is your activation force, right? Now we will need to find out the brake factor thing. So the frictional torque on the drum. So what have we talked about earlier? So the road adhesion torque. Now we talk about frictional torque developed on the drum, right? So what your activation force, the activation force, then a radius of your drum, okay, This is the way the brake factor will come into the picture. Okay, this is the way the brake factor come into the picture. Brake factor, a BF. Okay, it's a BF. So what is the actuation force? 4,410. What is the radius of the drum brake? It's a 0.125. Do we know the braking value? Are we knowing the brake factor value? We don't know, right? We have to find out. So that's the equation number 2. But the concept would be, we know that whatever the brake developed by the drum must be equal to the brake developed by the vehicle. That has to be equated. That has to be matched. So if we do equations, equating equations equal to 2, so I can find out, and this is what 1 into 1015 10 power 3. This is so much Newton meter. If I do that, 4,400 into 0.125, I will get the BF. Okay. So my braking factor, it should be right 1.842. So already we got it. Right. BF we got it. So braking factor. So this depends on what? This braking factor depends upon mu L and the dimension of drum brake. Okay, right. So, but we know that what is the leading sheave factor and the trailing sheave factor. Okay, but we don't know the values of mu L. So we have to substitute the mu L value by varying 1, 2, right, a 0.1, 0.2, 0.3, 0.4 like that, until you meet the braking factor, the values. So when it meets, that's a corresponding mu L value you should provide based on the SAE standard. Right. So we are going to use the trial and error method. Right. So mu L, I am just going to have mu L here. I need to find out the leading, S leading, S trailing, right. Then my braking factor BF equal to S leading plus S trailing. So we are going to have a table forming. So what we are going to do, we will change the value. First we will try with the 0.1, right. So already we derived what is the S leading, right. You substitute mu L equal to 0.1, find out what is the value you are getting. So you would expect leading will be always higher value to 0.211 and this will be 0.172. So together when you add 0.383, right. So similarly if you do change the mu L 0.2, right. So 475, 0.315 and 0.7902. Similar, I keep increasing. What is the brake factor you are getting? Already we achieved. The brake factor should be 1.842, right. Until then you will keep increasing your mu value. Until then keep increasing your mu value. So 0.816, 0.432, 1.252, then I will go for 0.4, 1.272, 0.540, 1.812, but ours is 1.842, still it is not correct. 0.5, so that will be give 1.915, 0.629, and 2.544. Right. So what is the brake factor we have? Brake factor we have 1.842. So if you do this between these two values, interpolation, you will expect mu L based on interpolation, right? You expect mu L equal to 0.404. Okay. Now, if you refer your SAE standard, okay. So what is the code you are expecting? Right. So mu L is given 0.04. So it's in the range, right? It should be in the range. So what is the value you are expecting? As per SAE standard, what is the code? The code, friction lining code will be F value. Is it clear now? Yeah. So now you know how to select a friction lining, right? So you have to check based on the geometry, based on the type of brake system. Is it drum brake or disc brake? What happens if a disc brake? Straight away your BF will be 1.2, right? That is 1.2. It's a fixed. Whereas as you move on to the drum brake, within the leading and trailing, leading, or else servo dio or S-cam, these things will keep changing. Okay. So by doing trial and error method, finally you can expect your friction lining, right, based on the SAE standard code F. Okay. So let me ask few questions, okay, before proceeding to the friction materials. So far we have discussed the entire vehicle move in one surface, right, mu S, that keep changing. You can have a tar road, which is a bituminous road, or asphalt, that you can do that, or else you can have concrete roads, or else you can go for skiddy one, icy one, gritty, all those things we have discussed. That is as entire vehicle. My question is, when you travel in a narrow road, one side of vehicle will have on the mud, the other side will be on the road. So what do you expect? Understand my question, right? The same axle, one will have a different road adhesion factor, another will have a different road adhesion factor. So how it is going to be changed? It will be even more quite challenging, right? That's one thing you need to understand that. So another question. So far we have not discussed anything about the wheel drive, versus the front wheel drive or all wheel drive. So what happens when you have these drives? How is going to be affect the braking performance? Those topics I am going to give as a homework study. Okay, so I am going to give as a homework study. In fact, yeah, I will give some textbook also, you can refer it, right. I will ask in fact a couple of questions in the assignments based on that. Okay. So now I will move on to the friction material aspect, right. So we will talk about to only few minutes about the friction material. Understand the purpose of the friction material to develop the friction, right. It is to develop the friction. When you develop the friction, in the sense, the friction is not only developed but should be sustainable. If it is not sustained, you cannot hold the vehicle. So it should be sustainable, and not only that, it should have a high friction and stable friction. It should have a high wear resistance. You should not expect the brake wearing out quickly. Okay, that is third property. Fourth property, what do you expect? High thermal conductivity. Okay, if it's then only the heat dissipation can be easily carried away. Otherwise, if the heat is contained in the brake lining, that is going to affect the performance. Okay. Have you heard about brake fading? What do you mean by brake fading? What do you understand brake fading? It just fades away, right? What do you think of it? So when you apply the brake, right? When you apply the brake, so heat generated on certain points due to stress concentration, they will have localized heating. They will have localized heating. So because of that, you can't the harness mechanism will change. You can't hold it. You can't hold it. Okay. Maybe I'll give you some lighter example. Have you ever made chapati? Right? You have made chapati, right? So when you rolling on the skillet or tawa, you will see the block spots. Why the block spots coming? The heat supposed to be uniform. You use, you rotate so that the uniform it will come. Then flip it another side again, you will get puffed chapati supposed to be. But instead of that, you will have dark spots. Why this is coming? That's because of localized heat. So that's called hot spot. Same phenomena would occur in the brake pads also. Okay. Yeah. So again, so the brake pads, what happened? As the size of the vehicle change, the material also will change. For air cut application, you expect the temperature even 1000 degrees Celsius. That means that much friction need to be developed, and not only that, then the thermal conductivity accordingly should be increased. The wear resistance also increased. So there are you can't have a single material for a manufacturing brake. It will have a combination of many materials. That's why its brake material generally comes under composite material. Okay. One more question I would like to ask. Okay. The question is, you need to have a friction, you need to have a less wear, and you should have very high thermal conductivity, right? That is correct. At the same time, it should not have any corrosive behavior, because of when it exposed to open, right, the brake pads generally opens, the corrosive resistance should be very high. That is also very important thing. And more, when braking happening, what do you expect? The high noise, right? It's called squeal. Do you think is it comfortable for a passenger? So for passenger car, you have to think about the comfort also. You don't want to have a very noisy brake. So if you want to, that means you should be have very less noise. So if you want to have less noise, what are the things you need to change in the brake pad material combination, right? Then of course noise can be affordable for the off-road vehicle, by tractor, right, or in the gun where your tank. I'm talking about army tank. There is fine, high noise is fine. Okay, whereas as a human traveling, there you need to have a very comfort noise level. So depends on the how you want to. So based on that, the elements in the brake pad will keep changing. Okay, I think I'll stop. I'll give this also as a homework, because of it's a complete material aspect, not as much the design aspect. Okay, thank you.